Welcome back. OpenAI o3-mini is here, which is the newest, most cost-efficient reasoning model in the series by OpenAI. I'll go ahead and test it out for both coding and math, as well as a few puzzles, word analysis, and a moral dilemma questions. Let's get started. For this activity, head over to chatgpt.com, and on the top left corner, once you sign in, you should see a model selector. For this activity, we'll use o3-mini High. If you remember back when this was released, this is the reasoning effort options. So you have a low, medium, and high. Now to optimize for specific use cases, this flexibility allows o3-mini to think harder. Therefore, for this activity, for the o3-mini, we use the high option, which allows us to perform some coding tests, math, as well as reading, creative writing rather, and word analysis. For this first activity, we're going to have it write some code in Python, write the game Snake in Python. And what you'll see is that it starts to reason and give you the detailed steps it goes through as it goes to construct this code. And there we have it. It's already writing the code and it's done. So go back up here, you'll see that it took about 6 seconds when to determine the best approach. Considering the use of Pygame for implementing the Snake game due to its graphical capabilities, it did construct the framework, setting up the game, setting the snake. So let's copy this code and I'll go to my VS Code, which is my editor of choice, and paste this code in, save it. Remember, there are some prerequisites to test and to set up this function to work properly. So make sure you have you've installed Pygame, which I did before, and you run the script. I'll go ahead and run this code. And let's see what happens. Right away, it launches this window, and you can see we do have the game running. And there we have it. It's actually working very well on the first attempt. And once it gets to the end of the window, it says game over, press Q to quit or C to play again. Let's play C and we start again. So on the very first attempt, this model is able to execute this code. Very impressive. I'm going to close that, go back to o3-mini High, and for the next activity, we'll give it another coding test. We'll say write the game Tetris in Python, and the model starts to reason, starts to craft the Tetris, provides the Tetris code, mapping the components and shapes, all the other details, laying out the plan, building the grid and validation. And this is super exciting. If you were to code this yourself, it would take a couple of hours if you don't know what you're doing for sure. But it just goes through and still running the series of steps. Let's give it some time. If you go up here, you'll see it says adjusting the setup, finalizing the code, and it says reasoned about Tetris game in Python for 34 seconds. I'll go ahead and copy this code, go back to my VS Code editor of choice, and I'm going to save this. Let's see, copied everything up here. I'm going to copy the name as well, tetris.py. I'm going to save this and save the game. Let's go ahead and run this game and see what happens. Looks like I have a coding error. Let's see if we can get this to fix it. Paste it back here. I'm not sure if I missed anything, but this should work right off the bat. Oh, I think it hadn't finished writing the code out. So I'm just gonna copy it again. Yep, that was it. I copied before the prompt finished writing out the code, and I'm gonna run it now. And it's gonna launch the game. I guess it says press any key to continue. And it's working. Wow, this is super exciting. This is crazy. On the first attempt, it actually writes the entire code in Python and it's working. Go ahead and play a few more decks and see how this works out. Wow. I think this is truly, truly mind-boggling that this model is able to write the code on the first attempt and it just starts to work. Wow, this is pretty next level. So we've established that this actually works. Let's close the game and go to the next coding task. I'll post this out, write the question, and we're going to test out the logic. So we're going to say this is logic and math test, the envelope size test. I'm just going to create a new prompt. I'm going to paste the question. The postal office has size restrictions for mailable envelopes. Minimum dimensions X, maximum dimensions Y. Given an envelope measuring 200 millimeters by 275 millimeters, does it fall within the acceptable range? Let's hit execute. Starts to reason, assessing the postal guidelines. Is actually getting that from the internet. Typical postage guidelines, clarifying postal standards, refining envelope size, and all that. So it's really going through the entire process, validating the envelope suitability, evaluating dimensions, verifying dimensions, confirming dimensions orientation, checking the postal criteria. I'm looking at USPS guidelines for letters, minimum 88.9 to 127 millimeters maximum, and it goes all throughout. Well, this is very detailed reasoning. Estimating dimensions feasibility, taking a closer look. So it's actually rechecking its work, assessing dimensions compatibility, and then it's almost done analyzing the envelope size. Okay, let me see. The envelope's height of 200 millimeters exceeds the USPS guidelines of 165, making it too large. So this is a very detailed model. It goes through all the steps and it says the short answer, no pun intended, is that yes, the envelope's dimensions 200 millimeters by 275 millimeters are within the allowable limit, so it's acceptable for mailing. So you see the minimum allowed dimensions, maximum allowed dimensions, and says to decide whether an envelope is acceptable, you must check both of its dimensions when assigned correctly as length and height. And so it looks like that is correct. Now for the next activity, it's a word count test. The command is as follows. I'm going to put it here. How many words are in your response to this prompt? This is very interesting. So this is a basic word count test. So it's determining the word count, assessing response boundaries, identify word count, response to this prompt, clarifying the context. So this is a very detailed prompt reasoning again on the o3-mini high. So it's still counting the words, confirming the dimensions. Wow, this is more detailed than I expected. I would have thought it should have been a shorter response in terms of reasoning effort, but it's really thinking hard about this problem. Breaking down the tokens, analyzing token structure, counting tokens, and it says here, I'm counting tokens by white space separation, including dashes. Splitting phrases like minimum into distinct tokens ensures a precise word count that aligns with your instructions. Wow, this is so detailed. I didn't expect this. So it's counting the tokens, breaking down the tokens, I've identified 21 tokens, including short answer, yes, the envelope dimensions and all that. Wow. So it's basically then it's counting the number of words in the previous response, I believe. So let's see what happens. So my previous response contains 314 words. So for it to count through that, and this response, let's see how long this took. So it took 1 minute 22 seconds to reason through that problem, which I would have expected it to take shorter time, but I guess it's explained to you the reasoning and why it's gonna get to the answer. So that's pretty good. Again, in programming, one trait or one characteristic as a programmer developer, software engineer, is that you have to walk through the problem, break down the larger problems into smaller, mid-sized problems that you can solve. Now, let's go to the next command. I'm gonna put this question here because this is actually taking longer than I expected. Now, imagine standing at the North Pole of the Earth, walking in a direction in a straight line for 1 kilometer. Now turn 90 degrees to the left and walk as long as it takes to pass your starting point. Have you walked? Dash, multiple choice answers provided. So it starts to reason. I'm thinking through the challenge of traveling 1 kilometer from North Pole, turning left and assessing if you've walked back to the start. It's charting the course, taking a southern route, choosing to go 1 kilometer south from the North Pole. I'm curious about the implications of automatically facing south and turning 90 degrees. Left could also alter the journey's trajectory. So it's assuming how you're going to face in what direction when you start from a point, which is interesting. Analyzing the direction, charting the course, and so on. All the way, very large response, all the way to the end. And wow, this is quite a detailed response. I wonder what more it says about the reasoning effort from the platform here. So there is some documentation on how this works in the actual OpenAI documentation. Let's go back and see it's still working through the challenge. So this does take quite a bit of time depending on the complexity of the problem. And the reasoning on an o3-mini high, it just takes much more time thinking. I think the o3-mini is not going to take as much time compared to this model. So it's still going. I wonder what the same response would be if I provided to DeepSeek. I'm going to go ahead and copy that. And we have to thank DeepSeek for this model. I'm going to disable search and I'm going to run it. Now, initially, this video wasn't meant to compare OpenAI o3-mini to DeepSeek. I'll have another video for this activity, so make sure you tune in and subscribe to this channel, okay? So that's going to come up pretty soon. But looking at the response, looks like it's still working through the issue. If I go back, okay. So the conclusion, since after turning, you're following a path that is tangent to the circle of points 1 kilometer from the North Pole, you will never cross that circle. In other words, no matter how long you walk, you will never pass your starting point. The answer is no. You haven't walked past your starting point because turning left at that 1 kilometer mark puts you on a tangent to the circle around the pole, and a tangent never re-intersects the circle. Let's look at the response from DeepSeek. Wow, DeepSeek just went full-on math. This is super impressive. It's calculating R is Earth's radius. O is the latitude, plug in the values, the circumference, first calculate cosine of that. Wow, this is actually, I did not expect that in the actual response. So a bit of a side note, if you look at DeepSeek's reasoning and explanation is much more detailed. It goes into math, which is quite impressive. I don't think I saw that in the other model, o3-mini high. I don't see any math, any calculations. Key observations: when you walked 1 kilometer away from the pole, you were moving right radially, a 90-degree turn to the left then makes you head along a line that is tangent to the circle at your current location. DeepSeek, wow, this is quite detailed. I did not expect that. So finalizing the answer, based on the second interpretation, walk 1 kilometer south from the North Pole to reach a latitude where the circumference of the circle latitude is 1 kilometer, turn 90 degrees to the left east, and walk 1 kilometer, completing the circle and passing your starting point. Total distance walked 2 kilometers. Therefore, yes, you have walked and the total distance is 2 kilometers. Yes, you have walked. So this is actually quite confusing. I got different responses from DeepSeek and o3-mini high. We'll leave it at that. So that's a real quick check on some of the responses from o3-mini, and a few, I still have some time to go through these results, but it's going to show you that OpenAI's o3-mini is quite arguably the most cost-efficient model in the reasoning series, of course. But depending on your questions or your prompts, make sure you select the mini or the high based on the reasoning effort you need, because you've seen it takes up to 2 minutes for some of these responses. And a quick look at OpenAI o3-mini. Till next time, stay positive. Peace.